Welcome aboard Rocket Ship, the platform with the most relevant content for competitive examinations. This is Rocket Ship IAS Lab and continuing with our series on answer writing for general studies papers of civil services main examination. We take up a question that you might come across in GS paper 1. Here goes the question. Explain temperature inversion. Why has it become an issue of concern for India lately? So here the question requires you to explain a climatic phenomenon, actually something that is related with the climate. And in the second part, you have to talk about how this particular phenomenon has emerged as an issue that concerns India, that is actually leading to a lot of problems for India lately. So basically, you have to have some grounding in the current affairs to be able to answer these type of questions, you could say, comfortably. Anyway, we are introducing our answer with explaining the concept of lapse rate, which is actually a very common observation that temperature declines with elevation. You would have observed that temperature is generally lower on the, you could say, higher elevation. That is, the ground is warmer than up, that is, the ground is warmer than above. This is called normal lapse rate and it is equal to almost 6.5 degrees centigrade, 6.5 degrees Celsius per kilometer. That is, with almost every 165 meter, average temperature declines with height at the rate of 1 degree centigrade. Its practical implication is this is why the high mountains like the Himalayas, the Western Ghats, etc. are significantly cooler than the plains, and why pleasant hill stations have developed in the mountains. This is because, as we have just discussed, with almost every 165 meter, average temperature declines with at the rate of 1 degree Celsius. So you can understand very well that a place that is at an elevation of almost a kilometer above the mean sea level, it would mean that it is almost 6.5 degree. On an average, it is 6.5 degree cooler than a place that is on the that is around the sea levels. However, this observation is sometimes flipped, that is, it is reversed, and the near surface is cooler than above. That is, the surface air layer near the surface is significantly cooler than that the air layer above. This is referred as temperature inversion. You have seen it. It is actually a reversal of the normal behavior of air, where air generally cools with elevation. Here it is actually quite reverse, where the air near the surface is actually cooler than that above it. Here, betraying our expectations, the lower elevation is cooler than higher elevation. For the sake of present discussion, three types of inversion. There are actually many types of temperature inversion, but for the sake of our present discussion, because it is a GS paper, we are restricting the types of inversion, temperature inversion, to three. There are three types of inversion which are commonly observed in India. First is radiational inversion. Now try to visualize it through the graphic. What actually happens during the winters, actually the ground radiates heat faster and cools. We would repeat it: during the winters the ground radiates heat faster and cools. That means the air that is in contact with the ground, it is actually cold. It becomes cold and it is near the surface, while the surface the layer of air just above it is warmer still. This is actually inversion is all about. That is, there is colder air near the surface while it is topped by a layer of warmer air. Then comes frontal, which is often called advexional inversion as well. Frontal or advexional inversion as well. This is also observed mostly during the winters. What happens during the winters? Generally actually a cold front, which is a large mass of cold air, a cold front which is denser, it intrudes into the area of lighter warm front. We would like to repeat it. During the winters, what happens? A denser cold front invades an area of lighter warm front, and due to it being denser, it actually displaces it, and it actually rises above the ground. The warm front rises above the ground, and what happens? The layer of cold air, it is near the ground surface, while the warmer air is above. This is all inversion is all about. You can see here too, it is temperature inversion. The third type of temperature inversion that we are taking today is drainage inversion, which is observed in the mountain valleys. What happens during mostly the winters? It is again observed mostly during the winters. Again, the slope radiates heat faster and cools. That means the colder air that is upslope, it becomes cool. Actually, it becomes cold. The air that is upslope, it becomes cold, and it drains down the valley below, and it actually occupies the valley floor. That is why there is cold air in the valley floor, while there is still warmer layer above this cold air. This is all inversion is all about. Here we have seen that drainage inversion is observed in the mountain valleys mostly during the winters. Now, discussing these three types of temperature inversion in detail. During the winters, ground loses temperature through radiation and cools fast. The air near ground also cools while layer above is warmer. This is called radiational inversion. As we have seen that the ground radiates heat faster and cools. This is the actual cause of inversion. That is why it is called radiational inversion. And it is prime cause why frost forms on the ground. You would have observed that during the winters, you would have encountered frost on the vegetation, especially on the leaves. This is mostly due to radiational inversion. Then comes frontal inversion, which takes place when dense cold front invades and displaces lighter warm air from ground. The result is surface is cold. You can understand very well, as the lighter warm air has been displaced from the ground. The result is surface is cold due to contact with cold front, while layers of air above are warm. Frontal inversion is observed in northern plains during winter when cold fronts from Central Asia invade. During the winter, what happens? The large masses of air, cold fronts, they invade from Central Asia, and come to northern plains. Frontal inversion leads to forming of fog. One of the, you could say, consequences of frontal inversion is fog formation. Then comes drainage inversion, which is observed in the mountain valleys. The mountain slope, as we have discussed, the mountain slope radiates heat quickly, and layer of air upslope cools and becomes denser. This dense air drains downslope. The result is the valley is cooler compared to above. The valley is cooler compared to above or up. This is why, again, pay attention. This is due to drainage inversion that in the mountain areas, the native people build their homes. If anyone asks why in the mountain areas, the native people build their homes and farms on the upslope, this is to take advantage of the warmer upslope, which protects from extreme cold, snow and frost. So it is not as if temperature inversion is always harmful. In this case, at least, we have seen that the mountain people, the native mountain people, are wise enough to take help of temperature inversion to again build their home estate and farms, etc. on the upslope to, you could say, benefit from the warmer air and actually to protect from cold, snow and frost. Now, coming to why temperature inversion is suddenly of concern for India. Temperature inversion is a natural climatic phenomenon. However, lately it has become a matter of concern in India. As discussed in preceding paragraphs, during winter, actually it is the frontal advexional type of temperature inversion that is of great concern to India. During winters, cold air masses invade northern plains from Central Asia. Its interaction with relatively warmer air in the northern plains, it is actually the air above the northern plains is generally warmer compared to that coming from Central Asia. Masses from northern plains creates advexional inversion. The cold air near surface, now pay attention, the cold air near surface traps pollutants and inverted temperature prevents dispersal of pollutants. We would like to repeat it, as the layer that is touching the ground is cold, it actually traps the pollutants, and the temperature inversion, that is it, while it is topped by the layer of air which is warmer, it prevents dispersal of pollutants due to low wind speed. Actually, this results in heightened levels of pollution. You can understand very well that the pollutants are not dispersed. That would mean that there would be high levels of pollution locally. Move, dense fog also hinders transport. We have seen that frontal temperature inversion often leads to formation of fog, and you can understand very well that in the northern plains it is observed that during the winters all kinds of transport, rail transport, road transport, and sometimes even air transport, the air travel as well, is hindered. But again, the point is, it is a natural phenomenon, and we cannot escape accountability by blaming a natural phenomenon for pollution, whose very cause is entirely anthropogenic. We are not going to argue against this point that high pollution level in India is mostly anthropogenic. It is caused by human action. Move, temperature inversion only worsens the pollution levels. It did not cause pollution in the first place. What happens, because it prevents the dispersal of pollutants, this would lead to greater levels of pollution in locally. So this was all on temperature inversion, which is actually reversal of the normal behavior of air, where actually what happens in temperature inversion, the layer near the ground is colder than that above it. And we have discussed 3 types of temperature inversion, including starting with radiational inversion, then comes frontal advexional inversion, and third was drainage inversion, that is observed in the valleys. And we have also seen, due mostly to frontal advexional inversion in the northern plains, the pollution level is heightened as the pollutants cannot be dispersed. This was all on temperature inversion. We would bring you another lecture in a few days. As usual, we wish you all the best. Thank you.